Okay. Looking at our second example. A bag contains 7 black, B, and 3 red, which is going to be R, counters. 2 counters are selected without replacement, and that's something that's important to take note of. Find the probability of drawing, actually it says first of all draw a tree diagram, and then find the probability of drawing a black counter followed by a red one, which would be BR, 2 black counters, or exactly 1 red counter. Part 2 of the question is if the experiment was repeated with replacement, find the answers to the above questions now. Okay, first thing we need to look at whenever we have a worded problem is make sure we define our events. So I'm going to let B equal drawing a black counter, and R is drawing a red counter. The information that we have here is that there's 7 black and 3 red, so the total is 10. Probability of black is 7 out of 10. This is on the first counter that you select. And probability of getting a red counter is 3 out of 10. Let's have a look and put in a tree diagram. So our event is drawing counters. This is our first draw. This is our second draw. On the first draw, we could get black, red. And after we get black, we could get another black, or red. Or we could get, after we get red, we could get another red. Actually, I'll make that black first. So it's in order, and red. This one is black. Actually, I might name this B1 and red one, and this will be B2. So the first counter is black and the second counter is black. So I'll just put a little subscript 2 so we know this is the second draw and this is the first draw. So this one here is B2 given B1, R2 given B1, B2 given R1, and R2 given R1. Oh, it would be cool if that was R2D2. Need to make an example that does that. Probabilities. We need to add in the probability of getting a black counter in the first selection. Black is 7 out of 10 and red is 3 out of 10. Okay, let's think about if we do select black out the first time. So we've then, because we had 7 black and 3 red. So if we select 1 black, then we end up with 6 black left over and still all 3 reds are left. This is if black is the first one pulled out. So our total now is 9. So after we pulled 1 black out, our chance of getting a black again is only 6, because there's only 6 left over, out of 9, because there's 9 in total. So this is where the without replacement comes important, because we need to make sure we take that into account when we're working out these second probabilities. Chance of a red, given that we pulled out a black the first time, is 3 out of 9. Okay, now if we pull out red first, we're starting here, we end up with 2 reds left, and still all 7 blacks are there. We do have 9 overall though, same as before. So chance of getting a black after getting a red is 7 out of 9. Chance of getting a red after getting a red is 2 out of 9. Now to find these probabilities, we can just multiply. So this is going to be 7/10 times 6/9, which is 7/15. So I'll give you a moment to fill in the rest of the options. And you should have something like this. Good check, you remember from last time, is to check that these 4 options add up to 1. And they do. And I think that's our tree diagram, which was part A. Part B is asking for the probability of a black counter followed by a red one. So it's actually a probability of getting red 2 given black first. Red 2, black 1, so we can just read it straight off here, 7 out of 30. Probability of getting 2 black counters. B2, because we always put the second event first, given B1. It's bananas in pyjamas. B2 given B1 is 7 out of 15. Exactly 1 red counter. We could have R2 given, we'd have to have black for the other counter, or we could have probability of B2 given R1. So we could have the red counter coming first, or the red counter coming first here, or coming second here. And we just add those 2 probabilities together. And looking at our tree diagram, that is 7 out of 30 plus, I don't know why I've got a 9 here. That should be 7 out of 30. So if you copied mine, you might need to make that change. It's 7 out of 30 plus 7 out of 30. Which equals 14 out of 30. Or 7 out of 15, which is the same as the chance of getting 2 black counters, interestingly. Thanks for watching the video.